Now topic is traversal of a graph. Okay, so we know that traversing means visiting each node in some systematic approach. Okay, when we say traversing means visiting each node in a systematic, in some systematic approach. All right, so visiting each node in a systematic approach. We know that a graph is actually represented by its vertex and nodes, right? When we say a graph, it is going to be represented by a vertex, or we can call as a nodes, or and by the edges, right? Edges. So traversing traversing each of the nodes or each of the vertex is the traversing in graph. So we are going to study two different types of traversing methods. Okay, two different types of traversing method. Two types of graph traversing methods. The first one is called as your breadth first search, BFS. All right, breadth first search. So what is this breadth first search is? All right, so you know that in this technique, okay, first we visit the starting vertex and then visit all the vertices adjacent to the starting vertex. All right, and after this we pick this adjacent vertex one by one and visit the adjacent vertex, and this process goes on. All right, so what we have to do, we have to start visit the starting vertex, right, or starting nodes, and then what we have to do, then visit all the vertices adjacent to the starting vertex. All right, then what we have to do, then after this we pick this adjacent vertices one by one, then pick all these vertices. That means what type of vertices? Which type of vertices? Adjacent vertices. Adjacent vertices one by one. One by one. All right, one by one, and then visit the adjacent vertices, and the process goes on. And once we pick, then visit their adjacent vertices, and this process repeated. All right, so this traversing is equivalent to level order traversing of trees. Okay, so let us take a graph and traverse it using breadth first traverses. Okay, breadth first traverses. Let us take a graph. All right, so you can see that, let me take a graph. All right, let me take this graph. now let us put the directions. Now put the information 0, 1, 2, 3, 4, and this is 5, 6, 7, 8. All right. So here, this is one directed graph. Now let us take the vertex 0. Let's here step 1. Okay. Step number 1. Step 1. What is the step 1 says? Take 0 as the starting vertex. All right, so take 0 as the starting vertex. First, what we have to do, first we will visit the vertex 0, and then we will visit all the vertices adjacent to vertex 0. All right, so take 0 as a starting vertex, and then visit all the adjacent vertex adjacent to visit all the adjacent vertex of 0. What are they? They are, you can see what are they? They are 0 to 1, 0 to 3, and 0 to 4. So that is 1, 4, and 3. All right, these are the adjacent vertex of this one, vertex 0. Then here we can visit these vertices, these 3 vertices in any order. Either you visit 1, 2, 3, or 1, 4, 3, or 1, 3, 4, or 3, 4, 1, any order. Okay, so this is points to be noted. We can visit this 3 vertices in any order. All right, in any order we can visit this. Suppose we visit the vertices in order of 1, 3, 4. All right, suppose let's visit from, suppose we visit in the order, the vertex in the order, say that is 1, 3, 4. Now the traversal is like this. Now traversal is 0, 1, 3, and 4. So I'll draw only the part. So I'm going to highlight it with this one. Take a marker. Okay, let me take this. So 2, 3, 4, 5, 6. All right, I'll not draw the this one. I'll just draw what are required. Okay, I'm going to highlight this. All right, so from 0 to 1, then 3, and then 4. All right, put this one. So this is the traversal from 0, 1, 3, and 4. 0, 1, 3, and 4. Now first we will visit all the vertices adjacent to 1, then all the vertices adjacent to 3, and then all the vertices adjacent to 4. Got it? So first we will visit 2. All right, then 6, and then 7. Then 6, then 5 and 7. Alright, now note that this vertex 4 is adjacent to vertex 1 and 3, but it has already been visited, so we ignored it. Now the traversal is, got it? So till here it is understand. Now let me write the next point, taking the same thing. Now first we visit all the vertices. Next point, step number 2, first we visit all the vertices adjacent to 1, then all the vertices adjacent to 3, and then to 4. Alright, so first, so when we visit the vertices adjacent to 1, what are they? 1. So what are adjacent to 1? So first we will visit, so according to this we will visit, so I'll draw this one also, that will be easy. 6, 7 and 8, then 5 and 2. Alright, so first we will visit 2, and then 6, and then 5 and 7. So you have to note it down that vertex 4 is adjacent to vertex 1, right? Vertex 4 is adjacent to vertex 1 and vertex 3. Got it? 4 is adjacent to 1 and 3, but it has already been visited, so we ignore it. Now the traversal will be, so note, what is the note here? Note it is vertex 4 is adjacent to 1 and 3, but it is already been visited, so we ignore. Now the traversal is, what are the traversals? 0, 1, 3 and 4. This is first one, right? Starting value. Next is 2, 6, 5 and 7. 2, 6, 5 and 7. So let me draw this. So this is already 0, 1, 3 and 4. 0, 1, 3 and 4, and then we have to visit to 2, and then we have, this is 5, this have 6, and this is 7. So next point is, now we will visit one by one all the vertices adjacent to 2, 5, 6 and 7. Okay, 2, 5, 6 and 7. The next step is, what is the next step? Third step. Just step. Third step. So third step, what we have to do? Visit 1 by 1, hold the vertices adjacent to 2, 5, 6 and 7. Alright, adjacent to 2, 5, 6 and 7. We can see that the vertex 5 is adjacent to vertex 2, but it has already been visited, so we will ignore it and proceed further. Alright, now vertex vertex adjacent to 6 are 4 and 7, which has already been visited, so this is also ignored. Vertex 5 has no adjacent, right, has no adjacent vertex, right. Vertex 7 has vertex 5 and 8. This is your 8. You have 8 adjacent to 8, out of which vertex X has not been visited, so visit vertex 8. Alright, so vertex 8. So the traversal will be versal is 0, 1, 3, 4, 2, 5, 6, 7 and 8. So this is the traversals. So you will get the graph like this. Now we are going to highlight it. 0, 1, 2, 3, 4 and 5, 6, 7 and 8. So this is the, now we have to visit vertices adjacent to 8. Vertices adjacent to 8, that is your step number 4. So visit vertices adjacent to 8, but there is no vertex here. You can see that there is no vertex and there is no vertex adjacent to 8, so our procedure stops. So this was the traversals where when we take 0 as your starting vertex. Suppose when we take vertex 1 as the starting vertex, then applying above technique, we will get the traversal as 1 2 4 5 1 2 4 5 7 8 1 2 4 5 7 8. Okay, this was the that is known as your breadth-first search, BFS. Implementations of a breadth-first search using Q. So during the algorithm, during the process of any methods, so this any vertices will be in one of the 3 states: one, initial, waiting and visited. Okay, so at the start of an algorithm, or at the start of methods, or the beginning of the methods of the process, all the vertices will be in the initial state. When a vertex will be inserted in a queue, its state is going to be changed. Okay, so suppose we have a vertex here and we have a queue here. This is your queue. When it is going to be inserted, what will happen? Its state is going to be changed from initial. This is your initial and this is your waiting. So when it is going to be inserted, when will be inserted in the queue, its state is going to be changed from initial to waiting. All right, so when a vertex will be deleted, so in case of insertion, insertion, so when a vertex inserted, so inserted in a queue, when it is inserted in a queue, its state is changed from will change from initial to waiting. Got it? From initial to waiting. Now, and when a vertex will be deleted from the queue and visited, okay, number B, when vertex will be deleted from queue and visited, what will happen? Its state will change from waiting to visited. Waiting to visited. Now we are going to learn the different the procedures that we are going to be used here. So the procedure is as follows here. So the first, what does the process says that first, initially queue is empty. Okay, queue is empty and all the vertices are in the initial state. So insert the starting vertex into the queue, change its state to waiting. All right, then delete a front element from the queue and visited, change its state to visited. The third process is look for the adjacent vertices of the deleted element and from this insert only those vertices into the queue which are in the initial state. Change the state of all these inserted vertices from initial to waiting. And the fourth process says repeat step 2 and 3 until the queue is empty. All right, so these are the procedures. Now let us take an example to understand this. Solve this following this procedure. All right, so I'm going to take examples. Okay, I'm going to take an examples. So 0, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so this is my graph here. Now what will let us take so let's start solving this. Okay, let's start solving this. So let us take 0 as your starting value. Steps, right? First one, 0 as the starting vertex. 0 as the starting vertex. All right, 0 as your starting vertex here. Now as 0 is the starting vertex for traversals. Okay, now in each step, okay, we will, so from this figure different state of the vertices are shown by different colors. Okay, different states. So from this figure, in this figure we are going to show the different steps, or you can states of the vertices by different colors. All right, so we are going to use different colors. Second one is different colors shows different states of a vertices of the vertices. So we are going to take 0 as a starting vertex, and in this, from the figure, from this graph, we are going to show the different states of the vertices by different colors. Okay, so your this one, white will indicates initial state. All right, and the blue will indicate say gray. Let's take gray. Okay, gray indicates waiting state. Say for my this one I'm going to use pencil. Okay, so this is pencil is going to indicate waiting state. And then black indicates visited state. So we are going to use three different colors. One is white, which indicates initial state, gray is going to denote waiting states, and the black will denote the visited state. All right, so number one. So what we are going to do, what is the first procedure? It says insert the starting vertex into the queue and change its state to waiting. So what is we are going to insert? We are going to insert the vertex 0 into the queue. So as 0 is the starting vertex, so insert the vertex 0 into the queue. So when we insert this queue, so Q will be 0. So what will be this one? So what is the graph will look like? The graph will look like this. So let me draw with this one. Okay, so 0 is there. So I'm highlighting with this one. This is your 0, right? This is actually your 0. So what does 0 says? 0 means it is going to be waiting. So here in this waiting, and we highlighted with the gray 0. So 0 is changes state. All right. Next is second one is delete. So what does the second says? Delete front element from the queue and visit it, change its state to visited. Okay, so delete. We are going to do deletion. Delete vertex 0 from queue and visit it. So visited. So traversal will be 0. Traversal is 0. So traversal is 0. Now how is the graph is going to look like? So how is the traversal look like? So when we delete it, so visited, right? So visited. First we delete 0 and then mark as with this, and then delete a vertex 0 from the queue, and from the queue only. This was in the queue, right? So it will be deleted and visited it. So we are going to denote it with the black color. So this is denoted. So this is already visited. 0 is visited. So traversal will be 0, right? Traversal is 0. Now when its traversal is 0, what is the traversal says? Then vertices adjacent to vertex 0 are, what are the vertex adjacent to vertex 0? So you can see from vertex 0 means 1, 4 and 3. 1, 4 and 3. I'll take as 1, 3, 4. 1, 3 and 4. 1, 3 and 4. And all of these are in the initial state. So insert them into the queue. Okay. and all of this are in initial state. Initial state. So what does the second says then? Look for the adjacent vertex of the deleted element. That is, 0 has been deleted, right, and visited. From that, from there, insert only those vertices in the queue. All right. So those adjacent vertices will be inserted into the queue. All right. So in the queue, we will insert 1, 3, and 4. So insert will be initial state, so insert them. What are the vertex to be insert? So your q will be, what is the q here, will be 1, 3, and 4. 1, 3, and 4. This fourth step, repeat step 2 and 3. So that means 2 is going to be repeated, and 3. So delete front. So we are going to delete the front. So step 3. So delete. So what we are going to delete? Vertex 1. Right? The front is, your front is in the queue is 1. Right? So actually this is your queue. It is queue like this. All right, it was like this. So before that it was q was, it was like this. Here q, right, when q it was like this, only 0 and the remaining is empty. All right, so it was like this. So when we now when we transverse this, this 0 will be removed and you will get the q like this. This is removed. So 1, 3, and 4. All right, 1, 3, and 4. So 1, 3, 4. So what is the next vertex to be removed? So after 0, that is going to remove vertex 1. So vertex 1 will be removed from q and visit it. So your traversal will be 0 and 1. Traversal will be 0 and 1. Now vertices adjacent to vertex are, so adjacent vertex or to vertex 1 are, what are they? So 1 is 2 and 4. 2 and 4 or 2 and 4. 2 and 4. So vertex 4 is in waiting state because it is in queue. It is already in the queue, right? It is already in the queue. So vertex 4 will be in the queue. All right. So vertex 4 in the queue. So for this traversal, I'm going to draw the graph here. The graph will be like this. So traversal means black, right? So 0 is already visited, 1 is already visited. So I'm going to highlight it with the blue. Traversal. This is traversal. All right, traversal. Next is adjacent vertex to 1 and are 2 and 4. Right, are 2 and 4. Now vertex 4, that is vertex 4. Vertex 4 here is in the waiting state because it is already in the queue. Vertex 4 is in waiting state because it is in the queue. It is in the queue. so it is not inserted into the queue. It is already there, so it is no need of inserting. So it is not inserted in the queue. Alright, it is not inserted in the queue. What about vertex 2? Vertex 2 here. So vertex 2. So vertex 2, right? Vertex 2 is already in the initial state, so it is going to insert it into the queue. So vertex 2 is in the initial state, so it is inserted. So your queue will be what? Your queue will be 3, 4 and 2. So it will be like this. 0 is gone, 1 is gone, 3, 4 and 2. So 3, 4 and 2. Here we can see that why we take the concept of waiting state. So this is 2 is in the waiting. So 2 is waiting, right? So when it is said waiting means it should be highlighted with the gray. Alright. So why we take the concept of waiting is that, so we can concept, because vertex here, you see the vertex 4 is in the waiting state, that is already present in the queue, so it is not inserted into the queue. The concept of waiting state helps us to avoid insertion of duplicate vertices in the queue. Alright, so you can see that vertex 2 is in the initial state, so I have highlighted with your gray color. Alright, the gray color. Again, fourth, delete. So next step is delete, right? Vertex, what is the next vertex we have to delete? 3. So vertex, delete 3 from queue and visit it. Vertex 2 from the queue and visit it. So you can see that now traversal will be like, what will a traversal? Traversal will be 0, 1 and 3, right? So 1 and 3. So 0, 1 and 3 will be here. So 0, 1 and 3 will be highlighted with the black, right? White highlighted with the black. Now vertices adjacent to vertex 3 are 4. What are the vertices? 4 and 6. 4 and 6. 4 is in 6. 4 is already present in the queue, right? 6 is in the initial state. So we have to insert 6 into the queue. So your queue will be 3, 4, 2 and 6. So this is your queue. 3 will be removed, right? 3 is removed. 4, this one 3 is removed. No, 3 will remove. 4, 2 and 6. 4, 2 and 6. So how would the traversals look like? So your traversals, the graph will look like this. So this will be highlighted with the black because the traversal is 0, 1 and what is 3? 3 will be highlighted. So 0, 1 and 3. 2 is already in an initial state. So I will mark with the gray. 6 is also in the initial state. Yes, this is wrong. 4, not 5. 6. This is not 6. This one. This is 6, right? This is 6. 6. This not. Should be white. This is white. This is gray because 6 was the initial, right? So your queue is 2, 4 and 6. Next 5. So delete. So in the queue we have 4, 2 and 6. Now delete 4. Delete 4 from the queue, and visit it. So your traversals are 0, 1, 3, 2, 6 and 4 now. No, 0, 1, 2, 3 and 4, right? 0, 1, 3 and 4. Now what are the vertices adjacent to this? Vertex adjacent of 4 are, so if you see the graph here, 4, what are the 4 adjacent here? 0 is also adjacent, adjacent to 4. This is 4, right? 4 adjacent is from 4th side, right? 5 and 7. 5 and 7. 5 and 7. You can see that 5 and 7 are not in the queue, right? 5 and 7 both are in the initial state. So if they are both in this now, and both are in initial state, so insert them in the queue, insert them into the queue, insert them into the queue. Now in the graph 0, 1, 3 and 4 will be highlighted with the black color, and 2, 4, 2, 5, 6, 7 will be highlighted with the gray color, right? Now the queue will look like this. Queue is 4 is removed, right? 2, 6, 5 and 7. This is your queue. Now let me write like this: 2, 6, 5 and 7. Now the traversal will look like this. So the traversal will be, graph will be look like this. So this is 0, 0 will be highlighted with the black. This is 0, this is also 1, and what about this 1, 3? 3 is this one, so 3 will be highlighted. 4 is removed, right? 4 is removed, so 4 is also highlighted. This is 4. What about 2? This is 2, so I'm going to highlight it with the gray pencil. 5 is also initial state. 5 is already in the queue, so I'm going to make it with the 5, and then 6 also. 6 is, yes, already 6 is, 7 is also in the queue. So 5, so you can see that 0, 1, 3 and 4 will be in the black color, and then 2, 5, 6 and 7 will be denoted with the gray. Alright, next will be like this. Next is 5, 6. Delete. What is the next? Delete is 2, right? Delete, we have to delete 2. So delete is 2. 2 is the next element in the queue. So delete queue and visit it. So when we visit it, traversal will be 0, 1, 3, 4 and 2, and vertices are vertices adjacent to adjacent vertex is 5. You can see that from 2 to 5 only, right? Now 5 is already in the waiting state, because it is already present in the 5 is already in the waiting state. It, because it is already present in the queue, it is present in the queue, so no need to be inserted in the queue. So no need to insert. No need to insert in the queue. So graph will be same as your graph as same as graph will not be same because 2 is removed, right? So 2 3 4 5 6 7 8 9. So 0 will be removed, 1 will be removed, 2 is also removed. Now 2 is removed, right? Now what about 4 3 and 4? 3 is also removed, 4 is also removed, 3 4 is gone, 5 is in the highlighted state with the row with pencil, and then 6 is also still is there. So 6 is will be highlighted, 7 is also highlighted, a waiting state, right? This is in the waiting and this is deleted. All right, next 7, delete. What is the next queue, right? Queue is, what is the queue here? Queue is, for this one, queue is 0 1 3 queue is 5 6 7, 6 5 and 7. So now delete 6. So delete 6 and visit. So traversal will be 0 1 3 4 2 and 6. Now adjacent vertex are 4 and 7. 4 is already present in the queue, so it is already in the visited state, and 7 is in the waiting state. So nothing is to be inserted in the queue. So nothing is to be inserted. So queue will be 5 and 7. Here 4 is the visited. 4 is visited state. 7 is initial. That is waiting state. So no insertion. So Q will be 5 and 7. 5 and 7. So how will the graph will look like? How will the graph will look like? So let me take this. Alright, so 0 is black, 1 is black, 2 is also black, 3 black, 4 and black, and 6 is also black. So what about 7 and 8? 7 and 5, it will be highlighted with gray. So 0 1 2 3 4 5 6 7 8. So 0 1 2 3 4 and 6, right? That will be in black, that is visited, and 5 and 6 in the gray, that is in waiting to be inserted into the queue. Right, now here we can see why we have taken the concept of visited state. Here 4 is already is in the visited state, because that is it has been included in the traversal, so there is no need of its insertion into the queue. So the concept of visited state helps us to avoid visiting a vertex more than once. All right, next step is delete. So what was the next node to be deleted is 5 and visit it. Okay, so node to be deleted is 5 from the queue and visit it. And the traversals will be 1, 3, 4, 2, 6 and 5, and a vertex 5 has no adjacent vertex, right? So when we, and the queue will remain with 7. Now see this, here you can see that 0, 1, 3, 4, 2, 6 and 5 are highlighted with the black, that is visited, and 7 is the waiting, which is denoted by gray. Alright, next node to be deleted is 7 from the queue and visited. Traversal will be 1, 3, 4, 2, 4, 6 and 5 and 7, and adjacent. Alright, adjacent vertex of 7 is, what are the adjacent vertex of 7 is? Adjacent vertex of 7 is 8 and 5. So 5 and so adjacent vertex of 7 is 5 and 8. Now 5 is already visited. So no need to insert. What about 8? 8 is or not in the, it is in the initial state. 8 is in initial state. So 8 is inserted in queue. Right? So your queue will be 8. How is it graph will look like? So according to this, 0 to 7 will be highlighted with the black. So these are the black. 0, 1, 2, 3, 4, 5, 6, 7 will be highlighted with the black, and then 8 will as a gray. This one is the gray. So 8. So 0, 1, 2, 3, 4, 5, 6, 7 as the black, and 8 as your gray. And the last one will be delete. 8 is the only one that has to be is remaining in the queue, from the queue and visited it. So the traversal will be 0, 1, 3, 4, 2, 6, 5, 7 and 8. Since 8 has no vertex adjacent to 8 vertex at, now queue is empty. Now as the queue is empty, we will have to stop our procedures. This way we get the breadth first traversals when vertex is taken 0 as the starting vertex. So now before we proceed with the minimum spanning tree, there is one topic that is very important for you to understand the different methods of spanning tree. So the topic is design set in the data structures, how it is going to be helpful in finding the minimum spanning tree. So you can see that by the definition it says that it is a design set. Design set is actually a data structures in that keeps tracks of the set of elements partitioned into several designs, non-overlapping subset, or you can call as, in other words, a design set is a group of sets where no item can be in more than one offset. It is also called as a union find data structure. So we are going to study this, use this union and find data structure algorithms, as it supports union and find operation on subset. Okay, so let's begin by defining them. So it's what does this find says? Find operation says it determines in which subset a particular element is in, and returns the representatives of the of that particular set. Okay, an item can be this set typically act as a representatives of the set. And what does the union operation says? It merges two different subset into a single subset, and the representative of one of the sets become representative of another. The disjoint set also supports one other important operation called as a make set, which creates a set obtaining only a given element of it. So you can see that in disjoint set, we are going to use two operation. One is called as a find and finding of a particular element from a particular sets, and then your union operation, merging of two different subset into a single subset. Then just a second. And how this union and find works. We can see that we can determine whether two elements are in the same subset by comparing the results of two find operations. Okay, if the two elements are in the same set, they have the same representations. That means otherwise they belong to different set. That means if the two elements are in the same set, okay, they have the same representations, or you can call as that they belong to the same set. Otherwise they belong to different sets. If the union is called on two elements merged to element subset to which the two elements belongs. Okay, so this is how the union and find works, and how to implement. Actually, we are going to implement this one using array only. So disjoint sets for us are data structure which each set is represented by a tree data in which each node holds a reference to its parents, and the representative of each set is the root of that set's tree. So what is the find says? Find says parents allow follow parent nodes until it reaches the root, and union combines two trees into one by attaching one tree roots node into the root of other. So this is just a general idea how what is about what is a union and find data structures. Okay, so you finding of the find operation means finding of a particular element from a particular sets, and union is going to merge two different sets into or two different sets into a single sets. So let's see how it works.